Hello, sweeties! My name is JD, and today we are going to discuss a topic that's called the history of matter and atoms from ancient philosophy to modern science. In the 5th century BC, Leucippus and Democritus argued that all matter was composed of small, finite particles that they called atomos, a term derived from the Greek word for indivisible. They thought of atoms as moving particles that differed in shape and size, and which could join together. According to Leucippus' atomic model, the world is composed of an infinite number of solid, indestructible, indivisible atoms that interact with one another. And for Democritus' atomic theory, all things are composed of the atomos, or the fundamental particles, atoms. John Dalton F.R.S. was an English chemist, physicist, and meteorologist. He introduced the atomic theory into chemistry. John Dalton's atomic model, also known as the billiard ball model, describes atoms as solid balls that are indivisible and indestructible. Dalton's model was the first scientific theory to apply atomic philosophy to chemistry. New gases such as hydrogen, carbon dioxide, and nitrogen were discovered, and the phlogiston theory was widely accepted, but later proven incorrect. New elements were discovered, and Antoine Lavoisier introduced a new system of chemical nomenclature. Antoine Laurent Lavoisier was born in Paris, France on August 26, 1743. He was a French chemist and a leader in the chemical revolution of the 18th century. In the early 1900s, the most significant discovery regarding subatomic particles was the electron, identified by J.J. Thomson in 1897 through experiments with cathode rays, which established that atoms are not indivisible and contain smaller, negatively charged particles. In 1897, Thomson discovered the electron and then went on to propose a model for the structure of the atom. His work also led to the invention of the mass spectrograph. Wilhelm Ostwald suggested expressing relative atomic mass as 1/16 the mass of oxygen. He is also known as the father of physical chemistry. The theory from Wilhelm Ostwald is that all indicators are either weak acids or weak bases in which the color of the ionized form is different from the color before dissociation.